Hi, folks. My name is Omer. Today's talk is MQTT for home building automation hardware interfacing. A mouthful. I should have picked a shorter title, really. But we'll get started. Hopefully, the slides will only take a few minutes, and then we'll get to look at some cool demos. My name is Omer Kilic. Thanks to Frank for the good intro as well. Once again, I've worn many hats in the past, but the common thread has been embedded systems, and actually just sitting in between the hardware and software and cloud camps. And I'd like to call it the plumbing of the connected devices. And it's just, I find that to be quite an interesting challenge. So I run my consultancy, and I offer services around embedded systems design, Internet of Things, and electronics manufacturing. We also have Electrolama as our little hardware startup. We sell USB RF sticks, and very soon we're going to be announcing some pretty exciting edge nodes that we're developing, mainly for commercial use, but also home applications as well. I also decided to just go for a crazy OBS camera setup, and we'll see how well that serves me or fails me in a few minutes. So today we're going to talk about IoT for a few seconds, considering that the poll results suggest that a lot of you have IoT devices in your homes already, and there's some interest for those of you who do not have it. There's no point in spending too much time. Then we'll talk about one of the wireless protocols used in IoT deployments, Zigbee, which is fairly popular. And then the star of this talk is Zigbee to MQTT, which is a really neat project which links your Zigbee environment into, MQTT messages. And we'll look at like a standard Zigbee deployment, and then we'll switch over to the demo. Again, not going to spend much time here. IoT is just a lot of bulbous shapes and clouds and blue backgrounds. So it's multiple technologies, devices, connectivity standards, just connecting each other and talking to each other, really. And one of those protocols, the wireless protocols, is Zigbee. It is specifically a low power, low data network. You're not going to be streaming videos over Zigbee. It is mainly designed for battery powered and very low power applications, which is commonly found in home automation use cases. It is based on the 802.15.4 specification and builds on top of that by offering you features like security, and what's probably the most interesting part of Zigbee is that it defines clusters, which are, in simple terms, they're standard sets of messages and device behaviors that allow for interoperability across different vendors. So you can have your light bulb from one manufacturer, talking to, say, a remote from another, or like a little button from another manufacturer. In Zigbee, we have 3 different device types. So we have coordinators, and the names are actually pretty self-explanatory, but the coordinator is the orchestrator for the network, along with being a router, effectively, or a router. They are responsible for the bring up of the network, like setting up the PAN ID, security keys, extended PAN ID, and that kind of stuff. So routers are responsible for routing traffic between nodes. They're always on, so generally devices that are plugged in or have wall power are routers in Zigbee deployments. And end devices are usually battery powered devices, low power devices that have single parents. They do not route between the devices, and usually they're fairly good in picking the best route, but there are certain cases in which they might stick to a single parent. We'll talk about it afterwards. So in terms of the Zigbee topology, Zigbee can form mesh networks, which is one of the greatest things about it, and it works mainly, most of the time rather. Given that there's only one coordinator in any Zigbee deployment, routers are used to extend the range of the network and deal with, say, thick walls in a home, or well-insulated metal-clad surfaces. So routers are generally your way of extending the range of your Zigbee network and dealing with problems as well. All right, so that's enough theory. Let's talk about Zigbee to MQTT. In a world full of a lot of not so great software, Zigbee to MQTT is one of those things that just work. And it has a very active user community. And as the name suggests, it links your Zigbee devices to MQTT. But not just not just the standard or just the basic sensor readings, whatever. You can also do some pretty advanced things like binding different clusters to each other and so on and so forth. It integrates well with the common home automation frameworks like Home Assistant, and that gives you, say, app control or shiny GUI UI, web UIs and mobile apps and all that stuff. So the architecture of Zigbee to MQTT is, we can think of it as 3 separate components all working together. Zigbee Hertzman handles the core Zigbee communication. This is the lowest layer of the stack where you're actually talking to radio hardware. So think UART connection to a simple wireless microcontroller. And on top of that sits the Hertzman converters. This is responsible for mapping the individual device models, devices to the Zigbee clusters they support. So it's kind of translating the low-level Zigbee clusters into high-level presentation of those clusters. And Zigbee to MQTT itself is responsible for orchestrating it all and also keeping track of the state of the system. Very impressive number of devices supported by Zigbee to MQTT. This is from last night. I might have even added more devices by now. There's 1,796 devices from 259 different vendors supported currently. And for any devices that are not supported, there's a very active community developing and adding more integrations. And in the case your device is not supported, adding support is generally incredibly simple. It's usually just copy paste of existing defined converters. And yeah, it's just, if you're working on custom Zigbee stuff, it's incredibly easy to extend Zigbee to MQTT. Now, let's talk a bit about the deployment side of things. Usually you have, in a home environment, a Raspberry Pi is the greatest thing, of course, to run your little edge node. You generally need a separate MQTT broker, and you install Zigbee to MQTT, of course, and then you attach a little radio hardware to your device, to your edge node, and then that gives your little edge node the radio capabilities to talk to Zigbee devices. Now, what you run on it in terms of the front end, the rules engine, the cloud agent, possibilities are almost endless, but commonly rather, Home Assistant is one of those de facto standards of the kind of the automation space or home automation space. And you can also write a fairly simple adapter to link it to your cloud service provider of choice. Now, in the demo we're going to look at in a minute, with demo gods on our side, of course, things not breaking. We're going to have a little Raspberry Pi running one of the Electrolama sticks with Zigbee to MQTT, of course. There's a Mosquito MQTT broker running, and I'm gonna do some Elixir. Well, we're gonna look at some Elixir console output. Really, it's just a very simple, Hello World tortoise library demo. But we're gonna have a light bulb and a motion sensor and a remote, and hopefully we'll see some nice messages trickling through and have some lights. So without further ado, I'll just switch over to my terminal. So the top split here is the live MQTT traffic. So as I press buttons, you can see fairly verbose messages streaming across our screen, and you can see that the motion sensor is triggering every time I move my hand. There's actually kind of a hysteresis between actuations. So it doesn't trigger constantly. But then the motion sensor also has temperature output, which is great. And it's a nice 20.65 degrees in my room right now. And interfacing with any device becomes merely interpreting, the MQTT messages that you're receiving. And if you look at the code, I mean, the top level application just starts a process that sets up the connection for the MQTT server. And the main thing to set up is really the handler, the process that actually deals with all the messages coming in and out. And in this extremely simple demo, the handler literally just logger debugs the messages that we receive. But of course, this is where Elixir and Erlang shine, given the lineage and the historical connections. They are made for parsing messages, and I just simply didn't have time to make something cooler for the demo. But again, the possibilities are endless. And of course, we can also turn things on and off. I have a little party mode here in which let's start the party, right? If I can actually type. So we have a light bulb that is wildly turning on and off. It's very bright as well. This is not that exciting really, but oh, and I accidentally turned it off. I think it's sitting on an adapter. Anyway, we shall hopefully see it blink in a minute as I switch over to the web interface for Zigbee to MQTT. Yeah, it's just back online. I accidentally moved it too much, I think. So let's look at some pretty graphs. So this is the mesh network in its all glory. These are the devices in my house. We can see the blue. Oops, where are you going? The blue circle is our coordinator that is running away from the screen for some reason. And the solid blue lines are the direct links or direct connections to, well, from routers to the coordinator. And you can see the party bulb over here blinking as it's changing state and blinding me in the process. So we have a dedicated router here, just centrally located in the middle of our house. Its sole purpose is to be a router, but also all plugged in devices. So these are the light bulbs. They all act as routers as well. And if we actually, if we look at some of the battery powered devices, we'll see that they, instead of connecting directly to the router, coordinator, they are going through one in some cases several routers before they can reach the coordinator. So Zigbee to MQTT, as I've mentioned, supports interoperability between many devices. So in here we can see, a few different vendors and different models. And you can also, if you wanted to, as a kind of a lightweight interface to control things, you can control your devices through here. These are in the converters that we looked at, these are the characteristics exposed by each device that you can use to control your devices in. And if you're interested in the details of clusters and how they're mapped to kind of higher level constructs, you can look at directly at the clusters view in the device details. This won't mean much, and I'm not gonna have the time to cover it. But at the end of the presentation, there's I think it's about, I can't remember, maybe 600, 700 pages of a PDF that will tell you what these do. You can also do certain things, like bind endpoints to different devices, and this is kind of an advanced use case where you can, say, map one of the clusters. Or rather endpoints, exposed by your, say, switch button to your light bulb so that they can communicate directly without needing to pass through a coordinator or a rules engine. So what else can we see? So the map view is quite interesting, and it's kind of, you can see over time as you add more devices, and actually as you accidentally turn off some light bulbs, devices move across the network and find new parents for an optimum kind of a mesh route. But also there are, so much for standards, right? But there are certain types of devices, like some of these small battery-powered temperature sensors that I have, that just do not change their parents once they're set up, which is not ideal. And in those cases, actually making sure that you have permanently on routers deployed before you set those devices up is a good strategy. So going back to our slides, if you're interested in playing with Zigbee and just generally exploring kind of the world of wireless, this is important enough that I wanted to put it in the slide. Interference, especially when you have so many Wi-Fi networks around you, is a serious problem. 2.4 gigahertz Wi-Fi actually clashes directly with the Zigbee because they also operate on, well, Zigbee also operates on 2.4 gigahertz. And also, if you have your coordinator plugged directly in a Raspberry Pi and you have multiple USB 3.0 devices next to it, that can also cause a lot of interference. So the first link that we have is talking about the Zigbee and Wi-Fi coexistence. And you can use an app on your phone to scan for the Wi-Fi networks and what channels they're using. And then you can try and pick a channel that is not fully utilized or heavily utilized to set up your Zigbee network in with hopes that things won't change too much once everything is set up. The second is actually a white paper from Intel, which is quite interesting. It is talking about how, and it's an old paper as well, USB 3 is known to interfere with 2.4 gigahertz. In this specific instance, they're talking about dongles for keyboards and mice, etc. But also it applies to your 2.4 gigahertz radio sticks as well. And finally, the last link is from our friends at Unit 3 Compliance and EMC Consultancy, where we performed tests with the ZZH stick and a with Wi-Fi enabled and also a USB SSD plugged in, and you can see some serious noise on a spectrum analyzer and what can be done to prevent that from happening. So further reading, if you're interested in exploring the fundamentals further, the documentation from Zigbee to MQTT does a decent job. If you really want to get into the nitty-gritty of the clusters, you can look at the official spec. And so the demo I've shown you is, again, it's an extremely simple, hello world. I push the code, but you probably won't even need it. And you can also find a link to the library that we have there as well. I think that just about does it. Thank you very much for listening, and that leaves us, I think, with a few minutes for some questions. I'll also shout out to the Erlang priest for the last-minute Elixir help. Thank you.
So let's all give Omer a round of applause.
Thanks.
Silently. And I think we do have about 5 minutes for questions. So feel free to post to the Whova app, or I think it might even be possible for anyone with questions just to unmute now and ask them. Also, our poll has received 56 answers, and there's so many folks with so many IoT devices. Tell me what you're doing with them. I'm curious to hear about it. So while we wait for some questions, I did have one for you. You were pretty deep into Erlang, then you left, and then now you're kind of back, or a little bit. So happy to be back. I've fallen to the dark side of hardware and manufacturing, and now I'm back. So I'm wondering, now that you've had this experience going away and coming back, what are some of the things from Erlang that you missed and brought you back, or some of the things maybe that we could learn from your experiences? Well, it just was such a kind of, it reinforced the view that, oh, sorry, this is my timer. It reinforced once again the view that the way to look at building systems using Erlang principles, especially in hardware systems and embedded systems, makes so much sense, right? So I've been, from the sidelines, I've been watching all the exciting stuff that's happening around Nerves, and I actually can't wait to get Nerves running on one of the Edge node prototypes that I have. I feel it will be the perfect fit for it, essentially, right? Fail fast
and the inherent concurrency and parallelism that you get in hardware systems with so many things happening, it just makes so much sense. And I genuinely miss that. Every time I had to write some C# or Python to have like hardware interfacing, you know, I reminisced of the good old days, you know. So yeah, it's to say, I mean, nothing fun, you know, profound really, but it just reinforced the view that the way we're looking at, and you are looking at with nerves and all the embedded efforts you're supporting at how hardware systems should be built makes a lot of sense.
So it looks like we have a question. Manfred, would you like to ask it, or Omer, if you?
Oh.
All right. Well, I'll just ask.
How do you? Yes.
Yeah, right.
How do you handle the firmware updates of the Zigbee endpoints?
So that's a very good question. And if I actually switch over to Zigbee to MQTT web interface again, I forgot to talk to you about it. OTA over-the-air updates are actually supported. I will move the screen over there a little bit. As long as the firmware blob is published by the vendor, you can perform over-the-air updates just through the web UI, or actually, again, all of these, you know, commands that we're issuing on the web interface by pressing buttons, they all translate to MQTT commands. So you can, through MQTT, start an auto upgrade and actually get periodic updates on the progress as well.
Thank you.
You're welcome. I just saw the second bit of your message. Yeah, you should definitely check it out. As I've mentioned, Zigbee to MQTT is one of those projects that it's just so good, you know, because every time you have to write or interface with the middleware that usually runs talking to kind of these embedded coordinator stick kind of things, it's just, you know, it's reinventing the wheel every time. Whereas, you know, using MQTT as kind of the abstraction on the interface, it's beautiful.